This is section 8.5. We're going to look at properties of trapezoids and kites. This video, we're just going to focus on the trapezoids. Kites will be a different video. Here's an example of our quadrilateral family tree. This time it's presented as a Venn diagram. Everything in the box is a quadrilateral. So we have some parallelograms, we have some trapezoids, we have some kites. Those are different types of quadrilaterals because they all have different pairs of parallel sides. Parallelograms have two pairs. Trapezoids are not parallelograms, so they only have one pair of parallel sides. And kites are neither of those, so they have 0 pairs of parallel sides. That's how they're classified. We spent a lot of time looking at parallelograms. Notice how rhombi, rectangles, and squares live inside that parallelogram oval. That's because they're parallelograms. There's different types of trapezoids. We have isosceles trapezoids and right trapezoids to look at. Okay, so definition of a standard trapezoid would just be a 4-sided figure, a quadrilateral, with exactly one pair of parallel sides. So in this particular case, the top and bottom are parallel, but the left side and the right side are not parallel. Those parallel sides are called the bases. The sides that aren't parallel, those are called the legs. Now, we're going to have 2 different pairs of base angles. We're going to have one pair at the bottom here that appear to be acute, and we have another pair at the top that appear to be obtuse. That acute angle and that obtuse angle cannot be the same. But remember, if it's a trapezoid and you're getting parallel bases, those have to add up to 180. I'm going to switch that color real quick. Doesn't look like a great color. So if we were just going with a simple example here, if that angle was 70 degrees, this other angle at the top, it's obtuse, would have to be 110. Here's a figure in a coordinate plane. This is quadrilateral ORST. We need to show that this is a trapezoid. So we need to show one pair of parallel sides. And we're going to do that with slope. We're going to look at segment RS. And we're going to compare it with segment OT. Are they parallel? Well, we're going to find the slope by counting. From R to S, we're going to count up 2 units. And we're going to count to the right, it looks like 4 units. I went a little crazy with my highlighter there. Okay, so if you have a slope of 2/4, that's the same thing as 1/2. Now we want to find the slope of segment OT also. So we're going to do the same thing. We're going to count up, and we're going to count to the right to get from O to T. It looks like we're going up 4, and to the right, 8. So your slope there is 4/8, which is also 1/2. If your slopes are the same, remember, that makes parallel segments. Okay, so take a second and erase this. Maybe I'll erase it. Okay, that's better. So we just found that these are parallel segments, so we can mark them parallel. Now, for it to be a trapezoid, the other sides can't be parallel, because if they were, it wouldn't be a trapezoid, it'd be a parallelogram. So you got to do more work than just what we did. You have to check on segment RO and segment ST. it's pretty easy to see that they're not parallel. This isn't a coordinate plane, so it's drawn to scale. This guy is a vertical segment, clearly. Now, the only way for that to be parallel to segment ST is for it to be vertical as well, and it's not. You don't even need to count. That is not vertical. So that means these segments are not parallel. That's proof that that figure's a trapezoid. Okay? Isosceles trapezoids are specific types of trapezoids. That's when your legs are congruent. So notice the marks on the legs. When you have an isosceles trapezoid, different things happen. And it doesn't happen with standard trapezoids, just isosceles ones. So here's 3 theorems about isosceles trapezoids. Theorem 8.14 tells you that the base angles of an isosceles trapezoid are congruent. Now remember, there's 2 pairs. There's a pair at the top that are obtuse in this particular trapezoid, and then there's a pair at the bottom that are acute. Those are congruent base angles. So if we go back to that simple example we did earlier, if one base angle is 70, then you know the other acute base angle is 70. And you don't have the obtuse base angle measures, but remember, they got to be 110. Those angles are supplementary. Theorem 8.15 tells you that if a trapezoid has a pair of congruent base angles, then it has to be isosceles. So for example, if you just have a trapezoid, but it shows that one pair of base angles are congruent, you know that the other ones have to be congruent too. And there's one more theorem, 8.16. A trapezoid is isosceles if and only if its diagonals are congruent. So if you have an isosceles trapezoid, that means the diagonals are congruent, and vice versa. What if you have a trapezoid with congruent diagonals? Then it's isosceles, meaning the legs would be congruent too. We're going to use these theorems to do an example in our next video.